Hello guys, hope you're doing well. In this video, we're gonna study the integrals of trigonometric functions. We will do this in two steps. First, we will learn the basic integrals where the variable is just x. Then we will move to a more general form, where instead of x, we have u, and u is a function of x. This is very important because in many exercises, the angle is not simply x. So we need to understand both the basic formulas and how to use them when the input is a function. Let's start with the standard integrals. Number 1, integral of sine of x. We know that the derivative of cosine of x equals negative sine of x. So to get sine of x, we need a negative sign. So the integral of sine of x dx equals negative cosine of x plus c, where c is the constant of integration. Always check by differentiation. So the derivative of negative cosine of x equals positive sine of x. So the formula is correct. Number 2, integral of cosine of x. Since the derivative of sine of x equals cosine of x, right? So the integral of cosine of x dx equals sine of x plus c. Again, we can check the derivative of sine of x equals cosine of x, right? Number 3, integrals of secant squared x. As you know, the derivative of tangent of x equals secant squared x, right? So the integral of secant squared x equals tangent of x plus c. Number 4, integral of cosecant squared. Since the derivative of cotangent of x equals negative cosecant squared x, so we have the integral of cosecant squared x dx equals negative cotangent of x plus c. Number 5, integral of secant x tangent x. We know that the derivative of secant x equals secant x times tangent x. So the integral of secant x times tangent x dx equals secant x plus c. Number 6, integral of cosecant x cotangent x. Since the derivative of cosecant x equals negative cosecant x times cotangent x, so the integral of cosecant x times cotangent x dx equals negative cosecant x plus c. So let us collect the main formulas together. Number 1, the integral of sine of x dx equals negative cosecant x plus c. Number 2, the integral of cosecant x dx equals sine of x plus c. Number 3, the integral of secant squared x dx equals tangent of x plus c. Number 4, the integral of cosecant squared x dx equals negative cotangent x plus c. Number 5, the integral of secant x times cotangent x dx equals secant x plus c. And finally, the integral of cosecant x times cotangent x dx equals negative cosecant x plus c. These are the basic trigonometric integrals that come directly from derivative formulas. So what about the integral of tangent and cotangent? As you know, if we have a fraction where the numerator is the derivative of the denominator, the integral is simply the natural log of the denominator. Means the integral of u prime over u dx, u is a function of x, equals ln of the absolute value of u plus c. This is the key to solving the integrals of tangent of x and cotangent of x. Let's see how this works for the integral of tangent of x. As you know, tangent of x equals sine of x over cosine of x. So the integral of tangent of x dx equals the integral of sine of x over cosine of x dx. Now look at the denominator, which is cosine of x. What is the derivative of cosine of x? It is negative sine of x. Notice that we have a sine of x in the numerator, but we are missing a negative sign. But no problem, we multiply by -1 both inside and outside the integral to balance it. So we have equals negative the integral of negative sine of x over cosine of x dx. Now the numerator is exactly the derivative of the denominator, so applying our rule. So we have negative ln of the absolute value of denominator, means cosine of x plus c. And again, we know that cotangent of x equals cosine of x over sine of x. So the integral of cotangent of x dx equals the integral of cosine of x over sine of x dx. Now look at the denominator, sine of x. What is the derivative of sine of x? It is cosine of x. This time it's a perfect match. We don't need to adjust anything. So we have the integral of cosine of x over sine of x equals ln of the absolute value of sine of x plus c. So always remember to use absolute value bars because the domain of the natural log function is only positive numbers. Now let's move one step further. So far we integrate function like sine of x, cosine of x, and tangent of x. But what happens if x has a coefficient? For example, what if we have ax instead of just x? If the inside angle is ax, then its derivative is a. So when we integrate, we must compensate for that derivative by dividing by a, right? For example, the integral of sine of ax dx. As you know, the integral of sine of u with respect to u equals cosine of u. Negative cosine of u, right? So let u equals ax. Then du equals a dx. I differentiated both sides, right? So dx equals 1 over a du. So the integral of sine of ax dx equals the integral of ax equals u. So we have sine of u dx equals 1 over a du times 1 over a du. So we have 1 over a, the integral of sine of u du. And as you know, sine of u du equals negative cosine of u plus c. So equals 1 over a negative cosine of u plus c, and u equals ax. So we have the final answer, the integral of sine of ax dx equals negative 1 over a cosine of ax plus c. So the coefficient a inside the angle appears as 1 over a outside the integral, right? Or, for example, the integral of cosine of ax dx equals 1 over a sine of ax plus c. Again, the rule is the same. Since the derivative of ax is a, we divide by a, right? And the integral of tangent of ax dx equals negative 1 over a ln of the absolute value of cosine of ax plus c. For example, the integral of sine of 3x dx equals negative 1 over 3 cosine of 3x plus c. Or, for example, the integral of sine of 3x plus 5 dx equals negative 1 over 3 cosine of 3x plus 5 plus c. Or, for example, the integral of cosine of 4x minus 2 dx equals positive 1 over 4. The coefficient is 4. So 1 over 4 sine of 4x minus 2 plus c. Or, for example, the integral of tangent of negative 2x dx equals, the coefficient is negative 2. So we have negative 1 over negative 2 ln of the absolute value of cosine of negative 2x plus c. So we have the final answer is 1 over 2 ln of the absolute value of cosine of 2x plus c, because we know that cosine of negative x equals cosine of x. Or the integral of cotangent of ax dx equals 1 over a ln of the absolute value of sine of ax plus c. And as you know, the integral of cotangent of x dx equals ln of the absolute value of sine of x plus c, right? For example, the integral of cotangent of 3x dx equals 1 over 3, because the coefficient is 3. ln of the absolute value of sine of 3x plus c. So what about tangent squared of ax? For example, the integral of tangent squared ax dx. As you know, tangent squared u equals secant squared u minus 1. So tangent squared of ax equals secant squared ax minus 1, right? So the integral of tangent squared of ax dx equals the integral of secant squared ax minus 1 dx. So we have the integral of secant squared of ax dx minus the integral of 1 dx. And as you know, the integral of secant squared of ax equals 1 over a tangent of ax, right? And the integral of 1 dx equals x. So the integral of secant squared ax dx equals 1 over a tangent of ax minus the integral of 1 dx is x plus c. So what about cotangent squared of ax? The integral of cotangent squared of ax dx. As you know, cotangent squared of u equals cosecant squared of u minus 1. So cotangent squared of ax equals cosecant squared of ax minus 1. So we have the integral of cotangent squared of ax dx equals the integral of cosecant squared of ax dx minus the integral of 1 dx. And as you know, cosecant squared of ax equals, so as you know, the integral of cosecant squared of x dx equals negative cotangent of x plus c, right? So the integral of cosecant squared of ax dx equals negative 1 over a cotangent of ax plus c. So cosecant squared of ax equals negative 1 over a cotangent of ax minus the integral of 1 dx minus x plus c. That's it. It's very, very simple and important. So whenever a trigonometric function contains ax instead of x, the integral is almost the same as the basic formula, but we must divide by a, means coefficient of x. But don't worry guys, I'll be walking through plenty of examples in the next video. See you soon.